Hi and Assalamualaikum. My name is Nora Shazli binti Iran. I'm student from University Tun Hussein of Malaysia, Pagu campus, and I'm from second year student. In this video, I will share to you guys the basic motor design. For this video, I will show you how to build basic motor design. When you think of a motor, you may immediately think of a car or motorcycle, but it's actually there is another motors in your home every day. So which is if you put clean clothes or baju yang bersih dekat dalam washing machine ataupun eat food from the fridge, or use fan, you may use electric motor. In this electronic science project, you will make a simple electric motor with two magnets that talk each other, which is as they interact, they will attract liking, which is pulling together like this, or disliking, which is will push away. It cannot will push away from other. Like this. All the pushing and pulling will create some serious spinning, and that is exactly what a motor is, a spinning axle.
But you may have wondered just how does electric motors work. Have you ever played with magnet? So the magnet have a south pole and north pole. So they have two pole of magnet, which is same magnet will have two poles, or others magnet will doesn't have a label of pole. If so, you are well on your way to understand how simple electric motor work. Magnet produce magnetic field with north pole and south pole. If you try to push the north pole of two magnets together, they will not want to come together. Like this. Like this. The same thing happen if you try push two south pole together. If however you bring the north pole of one magnet close to the south pole of other, they will attract each other and stick together. Just like this and in summary, like pole, north or south repel opposite pole. North-south will attract. The stronger the magnet, the more forceful the attraction or repulsion is between them. As you probably seen, magnets are typically black, so there is no visible way to tell which end is north and which is south. You can detect the existing of a magnetic field and identify the north-south pole with compass. So basically, is my magnet have a label, and the original of magnet will black. So this one magnet is for playing to the children, and the magnet originally in electric magnetic, the magnet will be like this, and there's have no label south and north. So I will show you how I make the electric. So you can actually predict which direction the coil will push within, like this or like this, with Fleming left hand rule for motors. Hold your left hand out with the thumb, your thumbs, your pointer, and the middle finger at right angle to each other. Imagine an arrow at the end of these three fingers. Your pointer finger represents the direction of the magnetic field of the permanent magnet from north to south. pointing toward your palm to South Pole pointing away from your finger. Your middle finger represents the direction of electric current in the wire, which flow through the wire from the positive terminal of the battery to the negative terminal of the battery. The direction of force or push on the wire is predicted by the direction in which your thumb is pointing. When your thumb is pointing it up, or your thumb will pointing it down. So first we use the coil wire and make 10 turns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sandpaper to remove the make sure remove the exit of it will have to be like this. And for the second part, we will remove the half of the coil, right? So it will make the current will flow. So here I have a battery and a paper clip that I remove the plastic for the current will produce. I will wrap it.
So in my experiment, the coil is turned to down and up like that. So basically when the current is moving from negative terminal to positive terminal, the current will go up to the paper clip and the coil will turn around of it. This means the coil is actively pushed one half of each rotation while current is flowing. and through the next half while no current is flowing until it comes around to receive the next push. This allows the motor to spin continuously. If this is your first experience with electrical circuit, it is important to remember that electric current always need to a complete path in which to flow. Based on the drawing that I used show in this video which is a direction of current carrying coil will move when placed in a permanent magnetic field. The blue arrow indicate the magnetic field and the red arrow indicate the direction of the current, which is a positive terminal to negative terminal of the battery. The motion of the coil can be determined using Fleming left hand rule for the motor. Based on my video. So how? Did you learn something from my video? So I hope you will understand what I show you to basic motor design. So it will help you for your learning or your something project. So thank you for watching my video. Bye. Assalamualaikum.